Hello and welcome to this video on function notation. This is an introduction to function notation. There are going to be more videos in this series. Consider this function machine here, like you're probably familiar with. We have an input, which would be a number usually, so it could be the number 5 for example, and then you would follow the steps of the function machine and get an output. So in this one we'd do 5, we'd times it by 3, that's 15, we'd add 4 to that, that's 19, and that gives you your answer, your output. So an input of 5 gives you an output of 19, and when you put an input in you get an output, and that works for usually all numbers. Consider though the case where I want to do multiple things to my input. So let's say I have 5 again as my input, but I want to do 3 different things to it. So I square it, 5 squared, that's 25. I times 5 by 2, that's 10, and I add 1 to 5, that's 6. And then maybe I want to do something a bit more complicated here. I want to take that one and this one, and I want to add those two together. So 25 by 6, that's 31. And then I take this 10, but actually I want to subtract it from that, and that gives me 21, and that's what I want my output to be. Now, as a function, that's way more complicated. That's very difficult to see as a picture. Function machines don't necessarily work that well unless it's something a bit more simple like this one, our original function machine. So there's a better way of doing this using algebra, which is called function notation. The word notation just means how we write things down. So how do we write functions down properly in mathematics? And here's how. Every time you have an input from now on, I want you to imagine that's just the letter x. So x could be any number that we're going to put into the function machine. Then we follow the steps again, but instead of actually doing it for a particular number like we did 5 earlier, we do it algebraically. So we take x and we multiply it by 3. When you multiply by 3 algebraically, you would just write that as 3x. 3x means 3 times x. Then we take that 3x that we just got from this box and we go to the next step and we add 4 to it. Algebraically, that's 3x plus 4, like so. And then this is where things get a little bit different. The output is f and then x in some brackets like this, and we would pronounce that as f of x. That's how you read this thing here, f of x. That's our output. And those brackets don't behave like they normally do in algebra. So normally in algebra, if you have a bracket like, I don't know, 3x plus 2, you could expand that to get 3x plus 6. Those brackets aren't going to behave in quite the same way. This is just notation. It's just how you write down the output in this case. So don't think of those brackets like you normally do. So this here, f of x, simply means the output of a function. That's why we use f of function, when we put x in. So when I put x in, I get f of x out. Now we're almost done. Ordinarily, when you write down the solution to this, the actual function, you would write f of x first. You write the output first. So this function machine could be written as f of x equals, and then this bit here, the last bit we got to, the last bit of algebra, 3x plus 4. This simply means to get the output, this guy, what you do is you take your input x, you times it by 3, and then you add 4. That's exactly the same way of writing down the function machine that's in the diagram. And you can test it with a number if you wanted. Earlier we put 5 in and we got 19 out. Let's just check. So if we put 5 into here for x, we substitute that in, we do 3 times 5, 15, add 4, 19. So f of x would equal 19. Let's have a look at another example so you get to see what's going on. Again, we put our input as x, we add 5 to that. So adding 5 is just x and you add 5. Timesing that thing by 4. Now you've got to be really careful on this step because we want to times x plus 5 by 4. Some people would probably be tempted to write x plus 5 times 4, but that would only times this 5 here by 4. We want to times the whole thing by 4, so we put that in a bracket, x plus 5 all times by 4, and usually if you're going to times by something in a bracket, you would put that number at the front. So let's move that to the front like this, and then that equals our output, f of x. So this one, written as a function, is f of x. A function of x is 4 lots of x plus 5. Let's try a different one. Input, again, x. We divide that by 2. X divided by 2. When you write that in algebra, you use a fraction. And then we're going to take this thing here, x divided by 2, and we're going to subtract 3 from that. So that looks like this. And then our output, f of x. So this one, written in function notation is f of x equals this one here, x over 2 subtract 3. Okay, here are 5 functions for you to try and write out using function notation. So press pause on this clip and then press play again, and I'll tell you what the solutions were. Okay, here are the answers then. For this first one, we have f of x equals x, you add 5 to it, and then you times all of that by 3. That was like our second example. And then this one here, f of x equals, well, you have x, you take away 4 from it, and then you divide all of that, and make sure this line covers the x and the 4 by 2. For this one here, f of x equals x divided by 3 plus 1. F of x equals x plus 1, and then we're going to square all of that. You need to make sure that bracket's there on the x plus 1, and then divide all of that by 2. And then finally, f of x equals 3x minus 3, all divided by 3. And that completes this video on function notation. Please make sure to watch function notation part 2. Thanks for watching.